So hello everyone. This is the Leetcode question of the day. Okay. So the question states that we have to find number of odd. We have to count the number of odds in the given range. So in the question, we will be given a lower limit and a higher limit. Okay. And then we have to return the count of number of odd numbers between this low and high. This is an easy question. You can easily figure it out. But if you are watching this video, then I assume that you weren't able to achieve answer this question, or there might be a possibility that you are searching for a different approach for this question. Okay. So there are various approaches, but there are two basic approaches for this question. First one is to iterate from this low value to high value and manually check if it is odd or even. So if it is odd, then I increment the counter, else then decrement the counter. I can show you this. Just create a very local variable count. Then this is the first approach. Okay, approach one. Okay, and in that just you have to return the count. Count is like a counter. It will keep record of number of odd values that we have gone. Well, there's no need to create a external variable to hold down the values. Just do this. Okay, I will explain everything. We will do a dry run on this question. Okay. So we'll start from low. We'll go up to a number where when low. Okay, I will do this. Okay, now we will start from low and we will go up to high until low becomes equal to high. Okay, we will keep incrementing the values. So now we have to check if low percent is percent to equal. Sorry, I think this will, because we have to calculate number of odds, okay, not number of evens. So what we can do is we can just do this, and we can count plus. Okay, what this means is, if let's say value of low is 3, okay, so if we divide 2 by 3, it will return 1. 1 means 2. Okay, in Boolean 1 means 2, 0 means false. Okay, so it will return 2. That means the counter will increment. It will take it as a odd number and counter will increment. Same goes for 5 and 7. Okay, same goes for 5 and 7. But there is a better approach than this. You can use bit operator like this. Okay, now this will do the same thing, right? Now if I run this question, what if you're not sure what this is, let me just give you an overview of that. Let's say we have 2. In binary, 2 is represented as 1 0. Okay, 1 0, and in binary 1 is represented at 1 is represented as 0 1, and just this left side 0 does not have any value. I'm just doing this to match with this one. Okay, and add. Okay, if we do an AND operation on this one, so the result will be AND operation. In AND operation, it's like a multiplication. Okay, if both are 0, okay, if both are 0, then the outcome will be 0. Okay, but if any of them is 0, then also the outcome will be 1, because 1 into 0 is 0. But if both of them are 1, okay, then in that case the answer will be 1. Okay, so in this case 1 into 0, it will be 0. 1 into 0, it will be 0. Okay, so we will be getting the output as 0. Okay, so in this case we will get the output 0. But let's say take the case of even odd number. Okay, case of odd number. Now 3 is represented in binary as 1 1. Okay, now if we do and on what exactly this happen, if we do an AND operation here, okay, let's remove 2. We do an AND operation on 1 and 3. Okay, I think this is the heading. Okay, now this is better. If you do an AND operation on 3, binary of 3 and binary of 1, okay, so 1 into 1, it will be 1, and 0 into 1, it will be 0. So we will get 0 1. and 0 1 in binary stands for 1. Okay, so we will getting 1, right? So in every odd number there is a and 1 add 1 at the end of the, binary representation. Okay, so if we make a odd if we make a AND operation, we do an AND operation on that number with 1, we'll get an output as 1 only if that number is odd. Otherwise we will getting odd, sorry, we will getting 0. Okay, sorry if I caused any confusion, but this is particularly used to check if this low is either odd or not. If it is odd, then it will go into the if condition and the counter will increment. Okay, otherwise it won't go into the condition and will just increment the value of low, and we'll move on to next value. But this is the costly approach. Okay, it will run. Let me check if it works or not. I've already solved this question. Okay, you can see that. Okay, this works. Okay, but this is a costlier approach. Now costlier, why? Because we have to traverse from low to high. Okay, and then we have to check for each value if it is odd or not. So there is no need to do that. Okay, I think it is a simple math question. So what we can do, let's see here. You can see yourself. This is 7, this is 3. Okay, so if you subtract 7 minus 3, you will get 4. Okay, so there are 4 values present in them, and it is inclusive one values. Okay, so including one of these values. Okay, so here 4, now 4 in case of 4. So we can use that approach to get number of values that can be odd or even in that case. Okay, so normally what happen is we include the lower values and exclude the higher values. I think I'm not making sense right now, but let me just code that so it will make more sense. Okay, so what we are going to do, we will be checking if low, that means if the first value like this, if the first value is odd, so using same approach, or this is a OR operator, or this is a unary AND operator. Okay, and this is OR operator, and if either high is odd. If any of them is odd, then we will increment the counter. Okay, if any of them is odd, we will increment the counter. If then after that incrementing the counter, we will do this count high minus low. Okay, divide by 2. Okay, so what this means is if any of them is what should I say, if any of them is odd, then we will be incrementing the counter by 1. If one of them if none of them is odd, then what we have to do is we have to just, because initially its value is 0, so what we will do is we'll just add the high minus low. In this case 7 minus 3 4 divided by 2. 4 divided by 2 will be 2, so we'll just add 2 inside this. Okay, so we will be getting 3 as our answer, like that. So let's just run it and check if it's correct or not. It's running for this one. Let's submit the question. Yeah, it worked. Okay, and I've already made a submission before also, and this beats 100%. Okay, so this is an efficient approach rather than doing it n times complexity. Okay, thanks for watching.